Hello friends, today we are going to learn about radial ball bearing, its construction and how to use it effectively in any assembly and how to understand the bearing specifications and also the limitations of ball bearing. Let's look at a simple animation showcasing the various components of ball bearing. This is the outer race and this is the inner race, and the groove what we see inside is called as the runway where the balls are rolling over, and this is the retainer which keeps the balls in its position. And in the assembled condition, the balls rolls over the track or the runway so that the outer race is able to achieve a very smoother rotation. So rolling over of the ball is the main function to achieve smooth rotation. As we can see in this video, there is a vertical and horizontal play because of the manufacturing clearances given to the inner race and outer race and the balls. So there will be a very minor play because of this. Okay, let us now see how in a simple assembly we can use this radial ball bearing and what are all the points we need to note so that its function is not affected during its operation. So this blue color shaded is our housing, and this is our shaft which we want it to rotate in this assembly freely. For that we are going to use our simple ball bearing and we are going to use circlip. In the assembly we will see where we are using and why. Before assembling this housing bearing seat area, this will be ground, and also the face where the bearing is going to set is also ground, so that accurately the bearing can set in the place. Now we have assembled our bearing in the bearing seat and we are going to use our circlip so that the bearing doesn't come out during operation. Now we are going to assemble our shaft. Here also we are going to use the circlip so that our shaft is also restricted to its position, and due to vibration or during running it doesn't come out of its position. So now this is a typical simple usage of a ball bearing in a simple assembly. Now let's see what will happen if we don't use the circlip. So with a gentle axial load, our shaft along with the bearing is easily able to come out. To restrict that, we need to use some element to arrest the bearing movement. Similarly, if our shaft we have not used any circlip or any other element to arrest its linear movement, with a gentle axial push, our shaft might come out. So to avoid this, we should always ensure in our assembly or during design itself, we should consider this kind of stoppers. Need not to be circlip all the time, but there are so many other ways to restrict its movement. Okay, now let us understand the bearing specifications. So the first letter, in our example we have taken 6205 bearing 6205 2RS. We will understand what 2RS is and also the bearing number. Okay, the first letter 6, that denotes the type of bearing. So the description of each number is also given here. So if it is 6, then it is deep groove ball bearing, and if it is 7, it is angular contact bearing, and similarly for every other bearing it will be denoted starting with the number like NU for cylindrical roller bearing. It starts with 3 for taper roller bearing, like that. The second letter, which actually denotes the width series of that particular bearing. So the second number denotes the width series, like 3 means some other width, 4 maybe a little bit wider than the 3 number, and being 0 and 8 is a narrow width bearing. Depending on the application, we can select the width what we require in our assembly, how much space we have, how much is the load carrying capacity. Accordingly, we can choose this. And the last 2 digit, that is 05, these to be read together always. The last 2 digit always denotes the internal diameter of this bearing. For example, if the last 2 digit is 00 or 01 or 02, the correspondent bearing diameter is given. So up to 03, this ID is common. Means 00 means 10, 01 means 12, 02 means 15, 03 means 17 mm internal diameter of the bearing. Above 03, that 04, 05, 06, the every number we can multiply by 5 and the result is the internal diameter of the bearing. For example, in our case it is 05, that is 05 into 5 is equal to 25 mm, that is the internal diameter of this particular bearing. Similarly, this goes up to 96, that is 480 mm diameter. 480 mm diameter. Above that 480 mm, the last 3 digit, that means one more digit will be added, and the last 3 digit will directly denote the internal diameter of the bearing. But normally in machine tools, we use bearing less than 500 mm diameter. But yes, of course, very big machines, special applications are there where the bigger size bearings comes into the picture. Okay. Then comes the last alphanumeric indications. That shows the type of seal used in the bearing to protect the bearing from dust entry. So the RS means the rubber seal. If it is mentioned as 2RS means both the side of the bearing they have used rubber seal. In the rubber seal also there are two types, one is contact type and another one is non-contact type rubber seal. So if it is 2RS, that means both the side rubber seal. If 2RU means both the side non-contact rubber seal they have used. In many of the cases we use metal seal also, which is denoted by double Z. I hope now this concept is understood of how the bearings are numbered, especially the simple radial ball bearing. So for your understanding, let us see, for example, if we want a 6007 bearing to RU, that means it is deep groove ball bearing and the 0 is the width series and the 07 means 07 into 5, that is 35 mm ID of the bearing, and 2RU means both the side the bearing is having non-contact type rubber seal. Yes, now let us understand the limitations of radial ball bearing. As many of us know, the radial ball bearings are not a favorable bearing in precision application because there is a small play inside the bearing created by the clearances what they have given while manufacturing the bearing. Like in the picture you can see there will be a very minor clearance between the contact points. That means this much of the value it can move radially, as well as in this case you can see it can move axially. So this creates a very minor small play in the radial ball bearings, and normally we don't use any preloading techniques to arrest this bearing for radial ball bearings. For those purpose there are special bearings which we can see in the upcoming topics. So what we need to understand from this bearing is these kind of radial ball bearings, simple radial ball bearings are not suitable for precision applications. That is like in the machine tool, like ball screw assemblies, spindle assemblies, those kind of precision application. We use some different kind of bearing which we will see in the upcoming topic, like angular contact bearing. See, because of this play, if the inner race and the outer race is loaded in these directions, so in the correspondent area it will touch, and this delta will be the gap it creates, or we can say the play. Similarly, if this is loaded the opposite direction, the contact point will become like this. So whenever we take this bearing, it is liable to have a very minor play which will be within this clearance value. Hence it is not suitable for precision application. Thank you very much. I hope this has added some value in your learning process. So please don't forget to like, comment and share. Thank you once again.